Let's say that we wanted to predict whether Google's stock will be up or down at the end of a particular month. Returns data for both Google and the S&P 500 are continuous. How can we convert this continuous returns data to up-down categorical predictions? Over the next few lectures, we'll see how to implement logistic regression in TensorFlow. In this lecture, we'll see how we can set up the baseline using basic Python libraries. This baseline will help us calibrate how well our TensorFlow model performs. In this logistic regression implementation, we'll set up a baseline using regular Python code. Our logistic regression code requires a bunch of helper functions. We skimmed over these helper functions in earlier lectures. We'll take a look at them now. We first use the same helper function which reads data for Google and the S&P 500 into a pandas data frame. We've used this helper function earlier in the demos for linear regression, so I won't go into the details of this. The return value is a pandas data frame which has three columns: the date, returns for Google, and returns for the S&P 500. It turns out that there are a few quirks in setting up data to be used in logistic regression, which is why we use another method to set up the data for logistic regression. This method is called read Goog SP500 logistic data. Code in here takes the same data from the pandas data frame. We start off in the same place for both linear and logistic regression. But in the case of logistic regression, we set up the data in a slightly different way. The first step in this function is to read in the returns data frame from the previous helper method that we just saw. And the second step is where the quirk comes in for logistic regression. By default, logistic regression assumes that the intercept is not included in its equation. In order to have the intercept included, we have to set up a new column in the returns data where every value in the column is set to 1. That is the intercept column, assigned to a scalar value of 1 within this data frame. If this intercept value were not present in the input to our logistic regression equation, the value of A in the logistic regression S curve equation will be left out. The addition of a column for the intercept implies that our X data now has two dimensions: the returns of the S&P 500 and our intercept column. We set up an array using np.array containing these two dimensions of data. In this X data, we leave out the first and the last row. We leave out the first row because it won't have a value for returns. This was true in linear regression as well. We leave out the last row of data corresponding to the last month as well, because each of our predictions of whether Goog is up and down is for the next month. We do not have any month's data available after the last month, so we can leave out the last row. The y values or the y data in logistic regression cannot be continuous variables. They have to be categorical variables because the objective of logistic regression is to find the probability of each of the y values. Y data is the returns for the Google stock, which is a continuous variable. We can convert this to a categorical variable by checking whether the returns for Google is greater than 0 or less than or equal to 0. If it's greater than 0, we assign a label of true, and if it's less than 0, we assign a label of false. If Google's returns were greater than 0 in a particular month, that was an up month for Google. Otherwise, it was a down month. So we assign to y data returns of Goog greater than 0, true or false values based on whether the returns were up or down. Return our two-dimensional X data and the one-dimensional categorical Y data as a tuple. Now that we have our helper methods set up, let's go ahead and set up our baseline implementation. Import pandas, numpy, and statsmodel.api. You're familiar with pandas and numpy. We've used it extensively in this course. Statsmodel.api is a Python library of statistical models. We'll be using the logistic regression estimator from this library. Read in our X data and Y data values using the helper function that we just set up, read Goog SP500 logistic data. This X data and the corresponding Y data then serve as the input to the logit class from our stats model library. This logit class provides a standard cookie cutter implementation for logistic regression. You can fit the logistic regression model to our data using logit.fit. This would fit the S curve on our data. The details of this S curve are not relevant at this point in time. What we are really interested in is whether this logistic regression model can predict up days and down days for Google stock. We use our logistic model result and call the predict function on it to predict up and down days for Google. X data is what our logistic model will base its predictions on. Remember that the output of logistic regression is a probability of a particular Y value. Let's say if the probability is greater than zero point 0.5, that predicts an up day for Google, and if it's below zero point 0.5 or equal to zero point 0.5, that's a down day. So our prediction probabilities are converted to true and false values. The predictions made using our logistic model are stored in the predictions array. Remember that our training data has actual Y values in the form of labels. We know whether Google stop was actually up or down in a particular month using these labels. We simply compare our predictions with the actual value of these labels to get an idea of how accurate our prediction is. We get the result true if our predicted value matched the actual value, and false if our predicted value did not match the actual value. And then we can count the number of trues to find how many of our predictions were accurate and store that in num accurate predictions. The percentage accuracy of our model is now a very simple calculation. We divide the number of accurate predictions by the total number of predictions and get a floating point value between 0 and 1. Print this out to screen and you'll find that our logistic regression model has an accuracy of 72.8. So, how would we convert returns data that is continuous to categorical values? We can simply say that if the returns in a particular month is greater than 0, that is an up month, and if it's less than 0, that is a down month. So, anything above 0 will be up, and anything below 0 will be down. Returns data will now have two categorical values, up or down.